All right, welcome. Today, we're going to talk about a revolution that's happening kind of under the radar. It's totally changing how we invent, well, just about everything. From the electric car you might drive someday to the grid that powers your house. We're moving away from physical trial and error and jumping straight to digital perfection. And it really all boils down to one single high-stakes question.
So, let's put you in the engineer's shoes for a second. You've got this brand new, cutting-edge microchip to design. We're talking millions of dollars, years of work, all riding on you. How in the world do you make sure it's going to work perfectly when the car it's supposed to go in hasn't even been built yet? This is what we call the engineer's dilemma.
You know, for the longest time, tackling this dilemma meant taking some absolutely massive risks. The whole process was just painfully slow. Mistakes were incredibly expensive. And get this, a single tiny flaw in the design could torpedo a multi-year project, sending everyone right back to square one. There just had to be a better way.
And that better way comes down to a choice between two very different paths. So, on one side, you have the old way, building physical prototypes. Every single test costs a ton of money and time. And if it fails, you might have to literally start over. But on the other side, you've got virtual simulation. This is the new path. It lets you test your design on a computer, maybe thousands of times, in all kinds of different scenarios, almost instantly, and for just a tiny fraction of the cost.
This is really the big pivot in thinking right here. Instead of building with actual physical stuff, engineers are now building with bits and bytes of data. They are literally constructing these huge, complex systems out of things you could call digital bricks.
So, what are these digital bricks anyway? Let's actually break down the key technologies that make this whole virtual world tick. And you know what? It all starts with making a perfect digital copy. Okay, this right here is the foundation of everything. It's called device modeling. The best way to think about it is like creating a perfect digital twin of a single electronic part. You know, a transistor, a battery, whatever. This software version, it's not just a drawing. No, it's programmed to act and react exactly like the real thing would. Under heat, under stress, with electricity running through it, it's a perfect clone.
So once you have your digital twin, you need a place to play with it, right? A virtual sandbox. That's where Spice comes in. Spice is the industry standard software that lets you take all these individual digital models, connect them all together, and build a virtual circuit. It's the program that lets you flip the virtual switch and see if your creation works or if it's going to go up in digital smoke.
Now look, this stuff didn't just pop up overnight. This technology has been evolving for years, growing from this niche thing in academia into the engine that drives pretty much all of modern design. And you can really see that journey unfold over time. If you look at materials from some of the industry leaders, back in 2002, the whole conversation was just about the basic question, hey, what even is device modeling? Fast forward 10 years to 2012, and it was already being used to teach the next generation of engineers in ebooks. And then, just a few years after that, by 2015, it was powerful enough to optimize entire solar power systems. That's a huge leap. So the takeaway here is pretty clear. This evolution from just a concept to this incredibly powerful tool has completely rewritten the rule book for engineering. It's faster, it's way smarter, and it unlocks designs that were just too risky to even think about attempting before. I mean, this all sounds pretty amazing, doesn't it? But it does bring up a big question. Where do all these super important digital building blocks actually come from? Well, to figure that out, we need to look at the model makers, companies like B Technology, who are really at the heart of this whole thing.
Because, you see, here's the catch. You can have the best, most powerful simulation software on the planet, but it's totally useless without a giant library of high-quality, verified digital parts. An engineer needs to be able to just grab any component they can think of right off a digital shelf.
6,866. Let that number sink in for a second. As of July 2024, that's how many Spice models, those digital twins we've been talking about, that one company, B Technology, has in its Spice Park library. That is a gigantic digital warehouse full of parts, just ready for engineers to start building virtually.
And they do way more than just stock the digital shelves. I mean, look at their services. They're a complete hub for this digital world. They'll create custom models for you. They verify that existing ones are accurate. They even help engineers solve those really tricky math problems that can pop up when a simulation just isn't working quite right.
So let's bring this all home. What does having a massive library of digital parts and all the know-how to use them, what does that actually mean for the tech that we're all going to be using in the future?
Let's just ask it directly. What does a service like this actually unlock in the real world? What can we build today that we couldn't even dream of building before?
You can see the innovation pipeline really clearly. It all starts with modeling a new cutting-edge component, something like a brand new LifeFull PO4 battery. Then from there, engineers can simulate and perfect entire circuits using that model. Maybe they're designing a game-changing all-solid-state battery system. And all of that virtual work directly accelerates real-world breakthroughs, like creating way more efficient motor drives for the next generation of EVs.
And that is why this is such a big deal. Whether you're talking about developing complex hybrid battery systems or just fine-tuning a tiny little stepping motor, the design, the test, the process of perfecting it, it all happens in the virtual world first. It's basically the mandatory first step to building anything new.
And that brings us to one last thought. We've seen how this digital blueprint lets us build faster, safer, and way more ambitiously than ever before. So if the only limit now is our imagination, our ability to model and simulate, what impossible problem are we going to solve next?